Okay, today we're going to talk about characteristics of quadratic functions. This is lesson 89. A couple of review points. Quadratics. A quadratic function means that our degree is 2, meaning our highest term would be an x squared term. And then also the graph will always be a parabola. So a couple key features on a parabola. The vertex is the point that's either going to be the highest point or the lowest point on our parabola. It will also be in the middle of the parabola. That vertex is either a minimum or a maximum. So it will be a minimum if our parabola opens upward, and that means it will be our lowest y value. And then we have a maximum when our parabola points down. Recall from the other day, our parabola opens down if our a value is less than 0. So that maximum then would be the highest y value on our graph. So I have a couple of directions for us to do for this next example. We're going to give the coordinate of our vertex. We're going to state whether it's a minimum or a maximum, and then we're going to review domain and range also. So here's our graph. We have a parabola. The first thing we want to look for is what our vertex is. Well, our vertex we said was going to be either the highest point or the lowest point, and in this case it's our lowest point. So right here on the y-axis is our lowest point. So our vertex is a coordinate point. So we say our vertex is 0, -4. Okay, that point right there. Then since our parabola opens up, we know we have the lowest point, meaning that we have a minimum. Okay, that minimum is also the point 0, -4. Then we get to our domain and our range. So domain refers to our x values. So we're looking at all of these x values along our parabola. Since it's a smooth connected graph, our domain will be all real numbers, meaning every single x value will eventually be used because this parabola keeps going up, and as it goes up, it widens out a little more and a little more and a little more. Okay, eventually it would reach all of the x values. Our range, however, talks about our y values, and not all of our y values are defined. So if we look for our y values, since y equals -4 is our lowest point, we have to say that our range or our y values are greater than -4. Here's another one I want you guys to look at. Same directions, just a different graph. Okay, so here's our graph. The first thing we want to talk about is the vertex. Again, and it is either going to be the highest or the lowest point. In this case, it's going to be the highest point right there. Give the coordinate point of it. So we go over 1 and then up 4. So our vertex is 1, 4. We're going to talk about the domain and range next. So our domain would still be all real numbers. This time our range, all of our y values have to be below that y equals 4, because remember, that's our highest point. So all of our y values are less than or equal to 4, meaning I don't have a defined y value at y equals 10 or y equals 6. If I looked at -2, I have 2 different y values, but none of our y values will be above that vertex. Okay, I want you guys to tell me whether our vertex is a maximum or minimum on this parabola. All right, next thing we're going to define on our parabola or on our graph is what we call the zero. The zero of a function or the zero of a quadratic means that our function value is 0. Well, function notation is f of x. That is the same thing as y. So we're looking for where are our y values 0. If you think of y equals 0, that's along the x-axis. So we're looking for x-intercepts. So looking at this graph, we want to find where are our zeros. In other words, what are the x-intercepts? So x-intercepts, remember, mean it crosses the x-axis. So our 2 x-intercepts would be +3 and -1. If you wrote those as coordinate points, it would be 3, 0 and -1, 0. Okay. We want to find the 0 of this function. Well, again, looking for an x-intercept. This graph never crosses our x-axis, so we just say that there are no zeros. I would like you guys to find the 0 of that parabola. Okay, another quality of a parabola, it always has an axis of symmetry. An axis of symmetry is an imaginary line that we could fold our parabola over, and it would fold in half. So we're looking for a vertical line that will divide our parabola in half. Well, since we talked about the vertex being the halfway point, our axis of symmetry will always go through that vertex. So that's something to keep in mind. The axis of symmetry will always go through the vertex. And we have a little formula to use. If we have our quadratic function in standard form, remember that's ax squared plus bx plus c, we can use this formula, opposite of b over 2a, to find our vertical line or our axis of symmetry. Okay, sometimes we'll be given a graph, though, that we need to find the axis of symmetry. So since we know our axis of symmetry divides the parabola in half, we're going to take our two vertices, our two x-intercepts, and find the halfway point to find our vertex. Well, to find the halfway point, we need to add our two intercepts, so -1 plus 3, and divide that by 2. When we do that, we get 2 over 2, which is 1. So our axis of symmetry would go through x equals 1 right there. And it does look like that vertex is at 1, -4. Okay, so there would be our axis of symmetry through x equals 1. So if you're given a graph, that would be how you find your axis of symmetry. If you are given an equation, you can use this opposite of b over 2a. So these next two examples, we use our equation to find the axis of symmetry. So we're given y equals -2x squared plus 3x minus 1, and we're asked to find the axis of symmetry. Using that opposite of b over 2a, we make sure our equation is in standard form, which it is. Remember, -2 is a, b is 3, and c is -1. So opposite of b would be -3 over 2 times our a value. Our a value is -2. Simplifying this, we get -3 over -4. And then we write our axis of symmetry always as an equation. So x equals +3/4 would be our axis of symmetry. And lastly, I'd like you guys to find the axis of symmetry for that equation.